Good morning, sir.
Very good morning, Dr. Khadim sir.
Yes, how are you, sir?
Fine, sir.
Okay, good. Sir, actually, we will start the session, okay, shortly, and participants are going to join.
Okay, right, sir. No issue, sir.
Himanshi, now it is 11:01. It can start the program. Amber? Amber?
Yes, sir.
बेटा स्टार्ट करवा लो प्रोग्राम को, है ना?
Yes.
लोग ज्वाइन।
Sir, we will start in a minute. Himanshi, you are not audible if you are speaking.
Hello, am I audible?
Yes, Himanshi, you are audible.
Okay, thank you. A very good morning, our Honorable Chief Guest, Professor Dr. Vikas Solanki Sir, CSE Department, Chitkara University, Chandigarh, Dr. Indu Prabha Singh Ma'am, AD Engineering, Dr. Khadim Moin Siddiqui Sir, HOD EE and EN Department, Dr. Vibha Shrivastava Ma'am, HOD EC Department, dignitaries, erudite faculty members, and all attendees. On behalf of IEEE, SPS, SRMCEM, and the entire IEEE SRMCM student branch, I, Himanshi Kapoor, Chair of IEEE Signal Processing Society of Sri Ram Swarup Memorial College of Engineering and Management, welcome you all for a workshop on hands-on practice of computer networks with Packet Tracker. I'm extremely elated to take this opportunity of expressing my heartfelt gratitude to our Chief Advisor, Professor Dr. Bhavesh Kumar Chauhan, sir, Group Director, SRMCEM, our Branch Advisor and SPS Advisor, Dr. Khadimuddin Siddiqui, sir, for their unwavering guidance and support in organizing the event. I would also like to take the opportunity of introducing the members of IEEE SPS SRMCEM Executive Committee, whose resolute efforts have made the conduction of the event possible. Himanshi Kapoor, Chair, Arunesh Mishra, Vice Chair, Lakshmi Singh, Secretary, Vartika Singh and Harsh Srivastava, Treasurer, Ananya Gupta and Adarsh Maurya, Webmaster, Kamal Bajpai, Additional Secretary. On behalf of the IEEE SRMCM Signal Processing Society, it gives me immense pleasure to welcome our Honorable Chief Guest, Professor Dr. Vikas Solanki, sir. Dr. Vikas Solanki, sir, is a faculty member in the Chitkara University Institute of Engineering and Technology, Punjab. He was a professor and director in Himalayan Group of Professional Institutions, Institute of Engineering and Technology, Kalam. Prior to this, he held the position of a professor and HOD, Department of Computer Science and Engineering at GNIEM, Naushera, Hoshiarpur, an associate professor and director, Mangalayatan University Institute of Engineering and Technology, Aligarh. He has vast administration experience with academic experience. He held other important administrative responsibilities like member of DRC, Academic Council, convener of Anti-Ragging Committee, coordinator of Examination Committee, senior superintendent of examinations in different colleges and universities. He has also organized a number of conferences and workshops in the capacity of convener, organizing secretary, coordinator. He did PhD in computer science and engineering under the supervision of Professor M. Qasim Rafiq. He has received MTech from computer science and engineering from Dr. AKTU, formerly called GPTU or UPTU. He has vast 24 plus years extensive teaching experience and more than 12 years research experience, and published, presented approximately 30 plus research papers in different international, national journals and conferences. He has published one book with international journal title, Frequency Sharing Schemes. He has also presented 6 patents in his account. He is paper setter and examiner in different central, state universities and private universities. He is also awarded as the best teaching faculty member by the Vice Chancellor, Mangalayatan University, Aligarh. Sir, now I would like to welcome on your stage. On the stage, the platform is all yours, sir.
Thank you, Himanshi. And thank you, Dr. Khadimuddin Siddiqui, sir. I am very pleased to organize or invite me as an expert in this workshop. I am not going in detail and don't waste the time because we have very less time and we just start the session. Dr. Khadim, if you allow me, then we just start the session. Dr. Khadim, sir.
Sure, sir. Sure, sir. You can start, please.
Thank you, sir. Thank you, sir. Thank you. I have shared my PPT. Is it visible?
No, sir, it is not visible.
Now I think visible.
Yes, sir, it is visible now.
Okay, right. This is the hands-on workshop on the computer networks using packet tracer. Basically, packet tracer is the Cisco software that is a simulator which provides the real-time experience to make the practice how we implement, design the computer networks. We will cover a number of topics in this workshop. Basically, basics of LANs, LAN with hub, LAN with switch, network using router, RIP protocol configuration. We don't go in detail in theory, and we will just make the practice or implement the networking using the Cisco packet tracer. First of all, you have to know how we can install the packet tracer in our system. You just go the website on NetACAD. NetACAD is the website of Cisco that provides the facility to download the packet tracer and conduct number of courses regarding to computer networking. You just registered your account, your profile on the NetACAD website, and
Excuse me, sir.
yeah,
Sir, sorry to interrupt. So the PPT is not in full screen mode. If you could just get it in full screen.
right. Now it is visible.
Sir, it is not in full screen mode yet.
But I have placed the PPT in the now.
See, you could do the slideshow option.
I have placed the PPT in slideshow.
So it is not visible in the slideshow option. Like it is not visible in the full
I
screen.
think some technical problem is
Okay,
there.
sir. Never mind, sir. It's okay.
Okay.
Thank you, sir.
Okay. Basically, we don't go deep in the theory, and there is no need to PPT. We go directly on the packet tracer. So don't worry. Don't take bother in the PPT too much. So you have to know how can we install the packet tracer in the computer system in your PC. You just registered your account in the NetACAD website and open your account in the NetACAD Cisco packet tracer website and just register your account in any course. The course is free. You don't require to take the some amount or registration amount. You just register your profile in any free course, and then NetACAD or Cisco allow you to download the packet tracer and work on the packet tracer. We don't go in detail in the theory. We just start the hands-on works on practice on the Cisco packet tracer. Basically, you know types of computers network. There are different kinds of computer networks, and which are classified into different category like LAN, MAN, WAN, PAN, CAN, TAN as per the size of the geographical area. So basically, LAN is the local area network, WAN is the metropolitan area network, WAN is the wide area network, PAN is the TAN is the tiny area network, CAN is the campus area network. So these are the some different kind of networks, but we don't go in detail in the theory. We just start packet tracer. If you didn't have your packet tracer in your PC, then as per the suggest here, you may download the packet tracer from the NetAcat website, register your account, register in any course. I have shared my packet tracer. Is it visible?
Yes, sir, it is visible.
Okay. So this is the interface of the packet tracer, and there are the number of devices, network devices in left bottom corner where my cursor is moving. This is the network devices button. This is for end devices button. As soon as we select these devices, it displays the number of devices regarding that. This is the list of different end devices, and this is the list of different network devices. This is the router. These are the switches. These are the hubs. We have list of the different network devices here. This is the working area where we will work and install the or implement the network. We just start very basic network. We select or we take two PC and we try to connect the two PC. Select the PC, first PC. We place the first PC here and the second PC. Then there is some problem in the cursor. I think I am trying to move the PC from this place. Okay, issue, we will delete it. This is the button to delete the any device. We delete it and select once again. Okay. So these are the two PC, and we will try to connect these two PC to each other. And to connect the PC with each other, we require a cable. This is the correct connection button. We select it, and we will select the cable here. This one is the straight through cable. This is the copper cable which have 8 wires, and jointly we call it cable. This is the straight through cable, and this one is crossover cable, and this one is serial cable. We use these 3 cables during the entire workshop. This one is straight through cable, this one is crossover cable, and this one is serial cable. As soon as we place the cursor on the cable at this side, we will see the name of the particular connectors, particular cables. And this is the copper straight through cable. This one is copper crossover cable, and this one is serial DCE cable. When we connect the similar devices, then we need crossover cable. And when we connect the dissimilar cable devices, then we need to connect straight through cable. We will select default cable from this packet tracer automatically handle this task. We will select it here, click it, and click on second device. We have seen that this packet tracer automatically select the crossover cable, this cable, because there is a dotted cable shows with dotted line. This one cable, because the devices are similar, and similar devices need to connect with the crossover cable. That's why packet tracer automatically select this crossover cable. We will select crossover cable directly. We delete it. First, we select this cable, and we need to, if you need to connect this, then use the fast Ethernet connection. Here we use the fast Ethernet connection, and as soon as we connect, the both ends shows the green signal, green light. That means the cable is jointly successfully. If we connect the wrong cable, then it shows red light, like delete it and select wrong cable, fast Ethernet, select fast Ethernet, like that. Here, when we select wrong cable, it shows red light. That means the cable is not connected successfully. Further, delete it and select right cable, connect with fast Ethernet. Okay, now we join the two different PC with the right cable, and this cable is crossover cable. When you would like to join the two PC on the network, then they should have a IP address. Without IP address, you cannot join or you cannot speak or communicate or establish the communication between the network devices. So first of all, assign the IP address to these PC so that these PC may communicate to each other successfully. So this is the basically edit button, and we place the edit button here, and we write here IP address. We write the IP address 192.168. Suppose 1.0. We take the IP address this, and here we also would like to talk about the subnet mask. Basically, subnet masks decide the network address as well as the host address. The IP address is the combination of two addresses. It talk about the two addresses, network address and host address. So here, when we talk about the IP address version 4, it has the 4 octet. The octets are separated by dots: 1 octet, 2 octet, 3rd octet, and 4th octet. These are the 4th octet: 1st octet, 2nd octet, 3rd octet, and 4th octet. These octets are separated by dot sign, like here. And now here we would like to freeze the 3 octet for the network address. These 3 octet for the network address, and 1 octet for the host address. So what we give the here subnet mask 255.255.255.0. That means 255.255.255. We freeze these 3 octet for network addresses and last 4th octet for host address. Similarly, we assign the network IP address for second PC 192 192.168.1.2. Here we assign the this is the network address. Network address of the network here is 192.168.1.0. You also need to decide the subnet mask here 255.255.255.0. So we decide the IP address of these two different PC. Here we decide only, not assign the IP address to devices. Now you have to assign the IP address to devices. This is the this is the decision. We take the decision to what IP address we would like to assign. We are going to assign the different PCs on the network. Here we have seen that when we place the cursor on the PC, there is no any IP address not set. Like that, here we place the cursor on second PC. We also seen that IP address not set. So now we would like to assign the IP address to PC. For that purpose, you click on the PC, go to desktop, assign IP address. Here IP address 192.168.1.1 and subnet mask. It takes subnet mask automatically 255.255.255. We may change it, but we are using here classful addressing scheme. Then it takes automatically as default classful addressing scheme and assign the subnet mask by default 255.255.255.0 and close it. Now further go here, select desktop, select IP configuration, assign IP address 192.168.1.2. यहाँ पर जो we have already decided that the IP address of second PC is 192.168.1.2. We here assign 192.168.1.2 and it takes automatically subnet mask, close it. Now we successfully assign the IP address. Now we have seen that the IP address is 192.168.1.1/24. Here 192.168.1.2/24. 24 is the subnet mask because we take the subnet mask 255.255.255.0. So 1 octet has the 8 bits. That's why 3 octets, 8 into 3, 24. That's why it in short write the /24. Now we check the devices are connected successfully or not. For that purpose, we have the ping command. Go to command prompt and this is the command prompt of PC0, first PC, and ping the second PC, ping IP address 192.168.1.2. This is the IP address of second PC. We ping the second PC with first PC. This is the command window of first PC and we ping the second PC, so ping and give the IP address of second PC 192.168.1.2, enter. We have seen that we got the reply and TTL value successfully. Sorry, that means now both PCs are connected successfully. Suppose if we remove the IP address from here, then we cannot ping the device. go to the command prompt and give the command again, ping 192.168.1.2. Then we have seen that request timeout. That means the devices are not communicated to each other. We didn't get reply and TTL value here, so devices are not connected here. If we further assign the IP address to the PC 192.168.1.2, then we further got the reply. We will make the communication or check the communication through second PC also. Ping 192.168.1.1 because the IP address of first PC is 192.168.1.1. That's why we give here the IP address. Then enter. We have seen that we got the reply and TTL value successfully. That means both devices are connected successfully here. And now, if you have any doubt at that point, you may ask. Your doubts are welcome at that point if you have any doubt. Any student? Am I audible?
Yes, sir, you're audible. Yes, sir.
Any doubt?
No, sir.
We go proceed?
Yes, sir, you are audible.
Yes, sir. You may proceed.
Okay, thank you. Okay, so here we connect the two PC directly, but we have seen that we have only one connector. Here we have seen that fast Ethernet connector, only one fast Ethernet connector per PC. But if you want to join more than one PC, if you would like to connect more than one PC to each other, then we need to another devices, hub and the switch. With the help of hub or switch, we may connect more than one PC or one devices, one end user devices to each other. So what we would like to hear that first remove the cable here and now take more PCs. Suppose here we have the now 5 PC. This is the network address 192.168.1.0, and we have already assigned the IP addresses of first PC and second PC. Now we would like to connect more than one PC. Then we need network device, either switch or hub. First we take the hub, select hub from this, take the hub. Now connect the all PC through hub. Now, when we connect the PC with hub, then we have seen that these are two different devices. In previous network, we connect two PC, which are similar devices. That's why we need this cable, crossover cable. When we need to connect two different devices, then we need this cable, straight through cable. So because here the one device is PC and the second device is hub, and we would like to connect these two different devices. That's why we need straight through cable to connect the PC and the hub. Select fast Ethernet, then fast Ethernet. You have seen that here we have on the hub side we have number of ports, more than one port, fast Ethernet port. So we may connect the number of PC, number of devices with the help of hub or switch. Okay, now here we connect the 5 PC with the help of hub, and it makes star topology. Star topology like that. Basically, if you have already discussed about the star topology, then hub or switch place into the place in between, and all devices are placed around the hub or switch like that. So it treated like a star topology. Whatever the physical arrangement, we may change the physical arrangement, but if the all devices are connected with the switch or hub, then we say that it is the star topology. Now, arrangement of these devices is definitely in a row, in a bus, but the topology is star topology because we connect all the PC with the hub, and hub is the central device, and all these devices are communicate through the hub, not directly. These PC cannot communicate directly. These PC may communicate through the hub only. Now decide the IP address of next PC, third PC 192.168.1.3 and subnet mask 255.255.255.0. Then decide IP address of fourth PC 192.168.1. सॉरी यहाँ पर 3 गलत कर दिया हमने, ये 2 गलत कर दिया, 3 होना चाहिए था, 3. ओके, 192.168.1.4 and subnet mask 255.255.0 and IP address of last PC is 192.168.1.5 and the subnet mask is 255.255.255.0. So we decide the subnet mask and like previous, assign the subnet mask to PC, go to IP configuration. This is the third PC. Assign the IP address 192.168.1.3, subnet mask, close it, then assign the subnet mask to fourth PC, 192.168.1.4, subnet mask, close it, then assign subnet mask to last PC, fifth PC, 192.168.1.5, subnet mask, close it. And now ping it. We ping the second, third, or fourth PC with the help of first PC. So ping and give the IP address of second PC 192.168.1.2. Enter. We got reply and TTL value. Similarly, you may give the IP address of third PC .3. Here we got reply and TTL value. That means the devices are connected successfully. Then fifth. Okay, we done it. All PCs are connected to each other through the central device hub. Basically, hub broadcast the packet. We have seen that with the help of simulator. When we go to simulation mode, select the packet from here, add simple PDU, select packet here, assign to sender and assign to receiver. This is the fifth PC. We assign to packet or envelope to first sender and to receiver, and go to simulation mode. Here, this is the simulation mode, and run the simulation mode. We have seen that the packet is go to the hub and it broadcasts the packet. That means send the packet to all devices, and only sender or receiver is receive the packet and other are discard the packet. It send the acknowledgement and further send the acknowledgement to all PC, and sender is receive the acknowledgement and other discard the acknowledgement. You may run further and see that basically hub broadcast the packets. That means send the packet to each devices available on the network, and only receiver receive the packet and send the acknowledgement, and further hub broadcast the acknowledgement and only sender receive the acknowledgement, and other devices, end user devices, discard the acknowledgement. Okay, come to the real time mode. Now, if you have or any student have any doubt till time, then your doubts are welcome. You may ask the doubts. Any student have any doubt? Am I audible?
Yes, sir, you're audible.
कोई डाउट नहीं है बेटा किसी को? Are you comfortable?
Yes, sir.
मेरी स्पीड में कोई प्रॉब्लम तो नहीं है? स्पीड फास्ट तो नहीं है?
No, no, sir.
Okay. We may go proceed further.
Sure, sir, you may proceed further.
Okay. Okay. So here we connect the all PC with the hub Now we may connect the PC with the help of switch. So here we remove the hub, we remove it, and now select the switch. This is the switch. We select the switch and connect the all PC with the help of switch. Because further we have two different devices to going to connect. That's why we select the straight through cable here. Basically, switch is the active device. That means it need the power. Hub is the device which come into both mode, active as well as passive device. But hub is suitable for connect less number of devices, less number of end user devices. And if you need to connect more than 7 device, then you would like to prefer switch. So here we have the number of ports. You have, as you have seen, that we have 24 fast Ethernet port here and 2 giga Ethernet port. Basically, giga Ethernet port has some high speed as compared to the fast Ethernet port. And if you would like to connect the LAN, local area network, then we need to connect the PC using the port fast Ethernet. So you may select here fast Ethernet. And here we have seen that at the end of end user device and PC, we have the green signal, and at the end of switch side, we have the yellow light. It takes some time to convert into yellow. As soon as the PC and the switch are synchronized, the light is automatically converted into green light. You have to wait for that. Yeah, it is converted into green light. It takes some time. When both devices are synchronized, then light is automatically converted from yellow to green. Now connect rest of the PC with the switch. Yeah, we have already assigned the IP addresses to all PC. Now give the ping command to check the devices are connected successfully or not. Ping 192.168.1.2. You have seen that we got the reply and TTL value. That means devices are connected successfully. The ping command is used to test the devices that are communicated to each other or not, they are connected successfully or not. If we got reply and TTL value, it shows that the devices are connected successfully to each other. Now, what is the difference between switch and hub? When we come into the simulation mode and run the simulation mode, we have seen that the hub broadcasts the packet. But on the other hand, when we connect the PC with the switch, with the help of switch, then first time it broadcasts the packet, but next time, after first time, it send the packet to a specific device, to sender only, not broadcast the packet. So basically, switch is the active device that maintain the MAC table, MAC address table. But hub cannot have any MAC table. It cannot, or hub cannot maintain the MAC table. So what are the advantage to maintain the MAC table on the network device switch? It sends the packet to a specific device, or it sends the packet from sender to receiver only. So packet cannot go to all device. So security of the network or security on the network is increased because the information go only to receiver, not other devices. So run this simulation, and we have seen that it sends the packet to receiver only, and receiver sends the acknowledgement, and then switch send the acknowledgement to sender only, not broadcast the packet, not broadcast the acknowledgement or packet. It sends the packet, it sends the acknowledgement to concerned device only. So this is the basic difference between the hub and switch when we connect more than one PC to each other. Now, if you have any doubt, then you may ask the question. Your doubts are welcome. Any student, if you have the doubt, then raise your hand and you may ask the doubt. Or you simply place your doubt in the chat box also. If you have any hesitation to ask the doubt, then you may place the doubt on the chat box. No doubt? Okay. So here we connect the more than one PC to each other with the help of hub or switch. But here, when we connect the more than one PC using the hub or switch, then all the PCs should be available on the same network. We cannot change the network. Like if we change the network here, or we assign the IP address of different network like 10.0.0.1 and assign the subnet mask 255.0.0.0. So this is the IP address of different network, not same network. Then this PC cannot be communicated 10.0.0.1. If we ping this PC ping 10.0.0.1, if you would like to ping this PC, then we have seen that request timeout. Request timeout. That means basically it's ping command send the 4 packet and check for the 4 packet, and all 4 packet we have received the message request timeout. Here we have seen that ping statistics for 10.0.0.1 packet sent 4, received 0, lost 4, 100% lost. That means the devices cannot be established the connection, cannot be established the communication. So we have seen that when we assign the IP address of this PC of different network, then it cannot communicate. But rest of the PCs have the communication. Like we check it, ping 192.168.1.2. We got the reply NTTL value for rest of the PC because rest of the PC are available on the same network. Rest of the PCs are available on the same network. That's why we got the reply NTTL value. So if we may connect more than one PC with the help of switch and hub when the all PCs are available on the same network. We cannot connect the end user devices PC with different network. If you would like to connect the more than one PC which are available on different network, for that purpose we need router instead of switch or hub. We need router. So here when we first of all you correct the IP address of this PC 192.168.1.5 and correct the subnet mask to 55.255.0. Okay, so this is the network 192.168.1.0 and we take the another PC which one is available on different network, connect these PC with the help of switch, select the switch. And suppose network for these PCs are 10.0.0.0, as we have already taken in the previous network for the PC5, which are not communicated to each other. Now connect the devices, because here we are going to connect different devices. That's why we have to select the straight through cable. And select the IP address 10.0.0.1, and subnet mask for this is 255.0.0.0. And further select the IP address 10.0.0.2, select subnet mask 255.0.0.0, and assign the IP address. Go to desktop, IP configuration, assign the IP address 10.0.0.1, subnet mask 255.0.0.0, assign the IP address to second PC 10.0.0.2, assign subnet mask, and we have seen that the ports are up and shows the green light. Check the devices are connected successfully or not. Ping 10.0.0.2. Yes, we got reply and TTL value. That means both devices are connected successfully. Now, if we would like to establish the communication in between two different networks, then we need a router. Suppose we try to check, we try to connect these two devices directly, or two different devices directly, establish a connection in between two devices directly. It takes some times to up the link and convert the green line to yellow line to green line. We have to wait for green line. Yes, converted, and check it. Ping 10.0.0.1. Request timeout. Request timeout. So these two different networks cannot be communicated because we try to connect these two different networks directly without router. So if we would like to connect two different networks, then you cannot connect directly to different networks. You need a router. First of all, delete the connection in between the switch, select the router. This is the router. We select routers from this and connect the two different networks with the help of router. Instead of directly connect the two different networks, directly connect the two switches, you connect these two different networks with the help of routers. So connect the routers with the help of cable. We connect these two different networks with the help of router, and we have seen that both ends shows the red light. That means the ports are down. Here we have seen that fast Ethernet port down, and we need to up the ports after assigning the IP address. The IP address of this network is 192.168.1.0, and the IP address of this network is 10.0.0.0. We have already taken. This is the IP address of this network, and this is the IP address of 192.168. 192.168.1.0. This is the IP address of first network, and 10.0.0.0 IP address of second network. Now we would like to assign the IP address of interface of routers. There are two interface, FA0/0. This is the interface of router for the network 192.168.1.0, and FA0/1. This is the interface for the network 10.0.0.0. Now assign the IP address to interface. This is the network 192.168.1.0. That's why assign the IP address of 192.168.1. Yeah, we have already assigned the IP addresses from 1 to 5. So we cannot assign the IP address from 1 to 5. That's why assign the IP address .6, and subnet mask is 255.0.255.255.0, and the assign IP address here, and this network is 10.0.0.0, and we have already assigned the IP address 10.0.0.1 to the. That's why I assign the IP address here 10.0.0.3, and subnet mask is 255.0.0.0. This is the, we just select the IP addresses of different interface of the router. Now assign the IP address of different interface of router. So click on that and go to CLI. Here we have seen that the message is, would you like to enter the initial configuration dialog? So by default, we take the default configuration. That's why press no, and further press enter. We have the prompt router. That's why we come to the router prompt. The name of the prompt is router here. We may change it using the host name command. If you would like to change, you may change it, but we are not going to change the prompt router. There are three mode of the router. This is the user mode, second mode is privilege mode, and third mode is configuration mode. So here we would like to go into the configuration mode because we would like to assign the IP address of the different interface of the router. So to go into the privilege mode, give the enable command enable or simply write en, enter. So now we come into the enable mode and go into the configuration mode, write config terminal, conf, you may write simply config t, conf, config t, or you may write entire command configuration terminal. Now we come into the configuration mode. So this one is the configuration mode, and at that mode, configuration mode, we may configure the router. So here, now we would like to assign the IP address 192.168.1.6 to the interface FA0/0. So then select interface INT, interface INT. This is the command to select the interface. You may write an interface or INT simply interface FA0/0. Enter. Now we come into the interface mode FA0/0 and assign the IP address with the help of IP command IP address 192.168.1.6 and 255.255.255.0. This is the IP address. Enter, and we have successfully assigned the IP address here. And to exit from the interface mode, simply write exit. We come into the configuration mode. To exit from the configuration mode, further write exit. Now we come into the privilege mode, and if you want to further go into the privilege mode, from privilege mode to configuration mode, further you may write config terminal as usual, previous command. Now select the interface FA0/1. To select the interface, we give the command interface or INT FA0/1. Now currently we are in the FA0/1 interface mode. Assign the IP address here. What is the IP address? 10.0.0.3. Assign the IP address IP add 10.0.0.3 and subnet mask is 255.0.0.0. Enter. Now we have assigned the IP address. Now exit from this mode, close the window and place the cursor on the router. We have seen that fast Ethernet, we have assigned the IP address 192.168.1.6 and fast Ethernet 0/1. We have assigned the IP address 10.0.0.3. But we have seen that link is down. At that point, after assigning the IP address, the link is down and the light is red. To up the link, we have the command no shut. Enter. Here we have seen that as soon as we go to interface FA0/0 and give the command no shut. As soon as we give the command no shut, we have seen that the light is converted automatically into green, and on the switch side the light is yellow. It takes some time to convert into green. We have to wait As soon as the devices are configured, the yellow light is automatically converted into green. Yes, it converted into green. Now further on the second interface, we have seen that still it is red. Now exit from the FA0/0 mode, select the interface FA0/1 interface and give the command no shut. So we have seen that the light is converted into green. You have to wait to convert the yellow light converted into green from switch side. Yes, it is converted. Now exit from the interface mode, come to the configuration mode, close it, and now check the both check both the networks are communicated to each other or not. We currently on the PC0. Go to the command prompt and give the ping command, ping 10.0.0.1, enter. First packet is lost, request timeout because it need to request timeout. That means there are some problem. The devices are not connected to each other. Okay, we check it. First of all, ping this port 192.168.1.6. Yes, it is connected successfully. It sent the reply and TTL value. Then check this one port, ping 10.0.0.3. No, it cannot receive the reply and TTL value. There is some problem. We check it. 192.168.1.6. We have assigned the IP address. Subnet mask is 255.255.255.0. we try to here give the routing, RIP routing. We give the routing. There may be some problem. Exit from the interface mode. Give the routing command. Router RIP and assign the network. NET network 192.168.1.0. Then next network is 10.0.0.0. Then exit, come to the configuration mode. Then try to ping it. There is some problem. We disconnect or we delete this and configure once again. I think there is some problem. Due to that, we are not able to establish the connection. Delete it and we connect the devices once again and further go to the CLI value. No, press enter, go to the privilege mode and then go to the configuration mode. And select the interface FA0/0, enter and give the IP address with the help of IP address command, IP add and 192.168.1.6 255.255.255.0. Yes, we done it. Then exit. Go to the another interface FA0/1. Then assign the IP address, IP add (10.0.0.3) and subnet mask 255.0.0.0. enter, shut up, no shut, no shut, go to the first interface, FA 0/0 and no shut, give the command no shut to up the link. Yes, links are up successfully as shown in the dialog box. Wait to convert the yellow line to green line. Yes, here we have seen check. Now we have assigned the default gateway. Oh yes, default gateway is not assigned here. Assigned default gateway. Default gateway is this, and the IP address of this is 192.168.1.6. This is a default gateway. Assign this default gateway to each PC because networks are different. That's why we have to decide, or we have to assign the default gateway 192.168.1.6. This is the only way from where the packet is go outside the network. 192.168.1.6 192.168.1.6 and assign the gateway for second network also, and the network default gateway of second network is 10.0.0.3. Assign the gateway here 10.0.0.3. Now give the ping command. Ping 10.0.0.1. Enter. First packet is lost here. Then wait for another packet. Another is also lost. Problem is not rectified. अभी इससे पहले ये वर्क यहाँ तक कर रहा था, ये यहाँ पर भी वर्क नहीं कर रहा है. इससे पहले we have give the ping command and it was pinged at the interface 192.168.1.6. Now it is not pinged to this level also. I think some problem is further there. I think we make mistake further. Otherwise, there is no reason to no problem at all. Select interface. Interface is FA0/0. Then give the IP address IP at 192.168.1.6 and the subnet mask is 255.255.255.0. No shut. And exit. Select another interface FA0/1 and assign IP address IP at 10.0.0.3 255.0.0.0 and no shut. Exit and close this. Wait to convert the yellow line to green line. Yes, converted. Further request timeout. Yes, we got the reply and time detail value. Yes, we got the reply and detail value. So we ping the another network. We are on PC5. We give the ping command for the another network, second network to first PC. The IP address of first PC is 10.0.0.1. Enter. We got reply detail value. You make further to device or second device. The IP address of this is 10.0.0.2. First, generally first packet is dropped, and after that we may got, yes, we got the reply and detail value. Yes, the network is communicated successfully. So here we have seen that we have assigned the subnet mask as well as gateway also, because when the packet is go beyond the network, then it need a gateway. There is only one way, one device from which the packet is go outside the network, and from this network the packet go from this network outside at that point, and the IP address of that point is 192.168.1.6. and when packet go outside from this network, then IP address of this point is 10.0.0.3, because the packet goes outside from this network by this path, and from this network by this path, and the IP address of this path is 192.168.1.6, and IP address of this is 10.0.0.3. So gateway for this network is 10.0.0.3, and gateway for this network is 192.168.1.6. So here we have seen that we assign the gateway also when we try to make the connection, make the or establish the connection, make the communication in two different networks. We need to assign the, I think some disturbance is coming from the Satya Verma side. Okay. So that's why we need to assign the gateway, default gateway also, when we establish the communication in two different networks using the router. And the router is basically used to connect the two different networks. If you have any doubt, then you may ask the doubt. I think at that point you have the doubt, because there may be some times to establish the communication. We repeat the connection more than one times. So you have the doubt, then you may ask the question. Any doubt? Himanshi?
No, sir, there are no doubts.
Okay. If you are comfortable, then we go to the two routers using RIP command. If you need, or otherwise, if you are comfortable to till now, then we may finish the session. You need to connect the network using two routers. Himanshi?
Sir, I guess we may finish the session for now, because we are having another meeting scheduled.
All right. Okay. Okay. Because time is too much. We have the near about the 2 hours. If you leave the session or finish the session right now, then okay. Okay, Manshi, over to you. I have finished my side. If you have any doubt, then you may ask the doubts.
Okay, sir. Thank you so much, sir, for this knowledgeable session. It was surely a valuable experience for all of us. So I would like to request the participants, if they have any doubt, they may post their questions in the chat box or they may raise their hands. Okay, so I think there are no doubts. So now I would like to invite IEEE SRMCM SPS Treasurer Vartika Singh to present the vote of thanks.
Thank you, Imanshi. Good afternoon to everyone. I would like to extend my token of gratitude to Honorable Director Professor Dr. Bhavesh Kumar Chauhan sir, IEEE Student Branch Counselor Dr. Indu Prabha Singh ma'am, Student Branch Advisor Dr. Khadim Moin Siddiqui sir, and RS Student Branch Advisor Dr. Vibha Srivastav ma'am, and to all the esteemed guests and participants. It's my privilege to have been asked to propose a vote of thanks on the expert talk titled Hands-on Practice of Computer Networks with the Packet Tracer. I, on the behalf of IEEE SRMCM Signal Processing Society, Lucknow, and on my own behalf, extend a very hearty thanks to Professor Dr. Vikas Solanki sir. Thank you, sir, from the bottom of my heart for taking time from your busy schedule to be the guest speaker at our seminar. Sir, the practical knowledge provided to us was phenomenal, and your excellent way of explaining the things made it quite easy for us to understand the concepts of computer networks deeply. It was surely a valuable experience for all of us present here that will help us in the best possible way. An event like this cannot happen overnight. It requires a lot of time and planning and a bird's eye for details. We have been fortunate enough to be backed by our management, our co-founders, Mr. Pankaj Agrawal sir and Mrs. Pooja Agrawal ma'am, and all the faculty members. Of course, it goes without mentioning a team of very motivated and dedicated student members of IEEE. I also extend my thanks to all the participants for their presence and careful listening. Thank you all for being with us this morning. Thank you so much, Professor Dr. Vikas Solanki sir, for your valuable time. Now over to Himanshi.
Thank you so much, Vartika. Now, sir, with your permission, we may end the session.
Yeah, Imanshi, thank you. Thank you very much.
Thank you so much, sir.
Thank you, sir, for this session.
Thank you.
Thank you, sir.